Hi everyone, in this unit we're gonna study the trigonometry of right triangles. Trigonometry is the study of relationships between side lengths and angles of triangles. We will see that the trigonometric functions are ratios of the lengths of two sides in a right triangle. So unit 2 is about using right triangles in trigonometry topics. Now, why is this specific to a certain type of angle? So if we are talking about right triangles, it means we have a triangle where one of the inner angles is a 90 degrees. So you have a right angle. That's what makes a right triangle. So let's say this is my right angle. I usually denote with the little square in the corner, just say this is a right angle, which is 90 degrees. So if your triangle has a 90 degrees, that is what we call a right triangle. If we're talking about the angles inside the triangle, right, between the edges of the triangle, it means we cannot talk about negative angles. This makes no sense to talk about negative angles for right triangles. It makes no sense for angles that are greater than 90 degrees as well. But we do know from chapter 1, unit 1, that we do have negative angles, and also we have angles that are greater than 90 degrees. For example, 180 degrees doesn't match a right triangle. It's impossible to fit inside a right triangle an angle of 180 degrees. So what we're doing now, we kind of initially define the trigonometric functions for acute angles. So we're talking about angles that are between 0 degrees and 90 degrees, right? But it's not going to be beyond that. So meaning only positive values up to 90 degrees. So later on, we have to expand. We also need to define this trigonometric function to other angles, the negative angles, to something beyond 90 degrees and so on. And that's why we're going to need actually the terminal side and the point on the terminal side of the angles, okay? But right now, bear with me. So we have right triangles. We know we can use them for acute angles. And we're going to define the trigonometric functions for the acute angles. The terminology we're going to use is that there is the right angle, and opposite to the right angle, the side that is opposite to the right angle is what we call hypotenuse. And that is because 90 degrees is the maximum value you can have for any angle inside the triangle. It forms the largest side. So the opposite side here is the largest side because the 90-degree angle is the biggest angle inside the triangle. So this is called hypotenuse. Now, the other two sides, which kind of form your 90 degrees, is what we call legs. So we have two legs. So this is one leg, and this is another leg. If I look at the other two angles, so let's call this angle right here alpha, and the other angle beta. So obviously they are less than 90 degrees. And by the way, the sum of all inner angles to be 180. And that's actually, you have a 90-degree angle plus whatever alpha angle is plus whatever beta angle is. The result has to be 180. Now, the sum of the inner angles of the triangle is 180, so we know that. So we know that these two guys together, the sum has to be 90 degrees, meaning themselves have to be less than 90 degrees. So they all acute angles. Now, these two angles, if I define the position of the sides in relation to the angles, they have other terms to define those sides. So let me use the same concept above. So the same triangle, assuming that's a copy, even though it's not exactly a copy, I cannot copy exactly. But I'm looking at the angle alpha, right? So the terminology is that the opposite side to alpha is this angle, like I pointed out for the other angle, the opposite side to alpha. So this is opposite of alpha. Obviously, this side is still called the hypotenuse. That doesn't change. But the other side, the one that touches alpha, it's what we call adjacent. Adjacent means next to it, right? So this is the adjacent.
Now, if I'm gonna look at the other angle that I call beta, let me pick a different color here, so here's beta. This now is the opposite side, right? In relation to the angle beta, the other side is the opposite. So notice that in relation to the angle we're talking about, these names, these concepts, these terms change, and it's based on the angle. So if that is the opposite, of course, right here, which I'm going to write in a different color, is the adjacent of beta. It's very important that when we describe the trigonometric functions, we describe in relation to what angle, because the values of the trigonometric function change according to the angles, right? It's based on the angle measure. So always specify which angle with regards to which angle the trigonometric functions are. And the same thing goes for the triangles here, because you can see depending on the position of the angle, the size of the triangle change names based on that position. So it's important to always determine what angle we're talking about. Okay, so these are just terminology, and that's basically what you have the first page there. And let me scroll down a little bit. So I actually want to go ahead and define the trigonometric functions. We have 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. So 6 trigonometric functions. And we define them according to the angle. So according to the angle, you have what's the opposite side of the angle and what's the adjacent. The hypotenuse does not change, but there's other terminology, adjacent and opposite, do change. Okay, so here are the definitions of the trigonometric functions. So we have that the sine function is defined as opposite over hypotenuse. And here notice that is specifically in relation to an angle. So if I call theta that angle, the opposite is here, adjacent is here, and of course the hypotenuse is here, right? So sine of angle theta is opposite over hypotenuse. I like to kind of shorthand this. So you're going to see me, instead of write the full name of the sides of the triangle, I'm going to instead write that sine of angle theta is opposite with regard to angle theta and hypotenuse. Now, I don't need to specify that the hypotenuse is about theta because it doesn't matter. Hypotenuse is the only side that remains the same for all angles that we're talking about. Now, cosine, okay? Cosine, which we abbreviate as cos, but normally we don't read as cos, we read as cosine. Cosine is the adjacent side of the angle divided by the hypotenuse. So the angle is theta in the picture. So we're talking about the adjacent of the angle theta divided by the hypotenuse. And then you have tangent of the angle theta, which is opposite over adjacent. But notice that I'm specifying that we're always talking about the angle theta, those kind of sides of the triangle. Now, the other 3 trigonometric functions, they are what we call reciprocals. Notice that if I flip the sine fraction, how I define sine, I have the hypotenuse over opposite. If I flip this, I have hypotenuse over opposite side, and that is the cosecant. Okay, so abbreviation of cosecant is this. So cosecant is hypotenuse over opposite of the angle. We also have the reciprocal of cosine. So the reciprocal cosine is secant. So secant abbreviation is sec. And we have that is hypotenuse over adjacent side. Finally, if we flip the tangent fraction, we have adjacent over opposite, and that is cotangent, so cot for short. So we have adjacent of the angle divided by the opposite of the angle. So you do have all 6 trigonometric functions, but I want you to remember that if you know 3 of them well, you always know the other ones, okay? Because the other ones are just flipping the fraction. And the question is, how do I remember which one are the pairs? Sine, cosecant. So notice that sine does not start with co, but the reciprocal start with co, right? So the reciprocal kind of flipping that, how you have this prefix in the word as a co. Cosine. Cosine starts with co, but secant doesn't. So again, the reciprocal, one has co, the other doesn't, so it's easy kind of remember that way. Tangent doesn't have the prefix co, but the opposite, I'm sorry, the reciprocal cotangent has the prefix co, okay? And basically you flip those fractions, you get all the interchangeable pairs there. So what we can say here, and it's good that I'm pointing out at this point, later on we're going to see what are the trigonometric identities, which are basically equations that work for all angles. We have that, for example, if I look at the first pair, which is sine and cosecant, they are reciprocals. Since they are reciprocals, I can write that the sine of theta is 1 over cosecant of theta. Remember, 1 over means you're flipping, right? And vice versa. So you can also write that cosecant, in this case, is the reciprocal of the sine function. Because again, you flip sine and you get whatever is the cosecant of the angle. Okay? And you can do that for all other pairs. Okay, so for now, we're only going to focus on the definitions in terms of the triangle. Here's one example, which is not completely solved in the textbook, but I would like to go over now. We have a triangle, which is a right triangle, where you have 2 legs. The legs have measurement of 5 inches and 12 inches, and there is the hypotenuse, which is 13 inches. Also, angle theta and beta are being designated in this triangle. So below the triangle, what we're going to do, we're going to define the trigonometric functions for each of the angles. So first, we're going to do the 6 trigonometric functions for the angle theta, and then we're going to do the 6 trigonometric functions for the angle beta. Okay? Notice that the exercise already gave you the 2 first definitions, which is sine and cosine. Sine of theta. Theta is this angle right here. Okay, it's highlighted in yellow. So since that is the angle, the opposite of theta is this side, and of course adjacent of theta is this side. So sine, which is defined as opposite over hypotenuse, notice that this is the opposite, this is the hypotenuse, is 5 over 13. And then you also have cosine of angle theta, which is 12. 12 is the adjacent, and then we divide by the hypotenuse, which is 13. All right, so that is the sec. So now what we're going to do is actually the tangent of angle theta. So let me erase these arrows that I create here because it's going to be better for me to write. So we're talking about tangent, which is opposite over adjacent, opposite of the angle over adjacent. Now, opposite is 5, and adjacent is 12. And again, the fraction is already in the lowest term, so there's no need for us to reduce further than this. Cosecant, which is the first function highlighted right here, is the reciprocal of sine, right? So if sine is opposite over hypotenuse, cosecant, I want a green color, cosecant is the reciprocal, which is hypotenuse over opposite. Now, the hypotenuse remains the same, doesn't matter which angle I'm looking at, and that is 13. Opposite of angle theta is 5. Now, again, if you compare the 2 fractions, right, is basically one is the flip of the other. Now, secant, which is the reciprocal of cosine, is defined as hypotenuse over adjacent. So in this case, we have that the hypotenuse is still 13, adjacent of angle theta is 12. And again, if you compare the two fractions, you have that one is the flip of the other, is the reciprocal of the other fraction. Finally, cotangent of theta, which is the reciprocal of the tangent, we have adjacent of the angle theta divided by opposite of theta. Adjacent is 12 and opposite is 5. Okay, and again, compare the two fractions. One is the reciprocal of the other. All right, guys. So the next one is now about angle beta. So angle beta is this, and that's what we're going to be doing here. All 6 trigonometric functions for angle beta. We start with sine. So sine is opposite over hypotenuse. So sine is opposite of the angle divided by hypotenuse. But now we're looking at the angle theta, which means the opposite is the side with 12 inches. So we have 12 over, and hypotenuse remains the same, which is 13. So 12 over 13 is the sine of angle beta. Cosine of angle beta is adjacent divided by hypotenuse. Adjacent, meaning the side next to the angle that forms the angle, is 5. And we divide by the hypotenuse, which is 13. Now we move on to the tangent of angle beta. Tangent is opposite over adjacent. So opposite angle is 12. I'm sorry, opposite side is 12 inches, and the adjacent is 5. Now, all other trigonometric functions are kind of reciprocal of the previous one. So we have again that cosecant is the reciprocal of sine. So therefore is defined as hypotenuse over opposite. Now the hypotenuse is still 13. Opposite of beta is still 12. But notice again that when you compare the two trigonometric functions, which in pairs they are reciprocal of each other, you have the flip of the fractions there. Now, secant, which is the reciprocal of cosine. So reciprocal of cosine means we have a hypotenuse over adjacent. So hypotenuse is 13 inches divided by the adjacent, which is 5. And again, if I compare the two trigonometric functions, cosine and secant, we have a reciprocal, right? We're flipping the fractions to get the other trigonometric function. And now we're dealing with tangent and cotangent. So cotangent, which is the reciprocal of the tangent, is defined as adjacent of the angle beta divided by the opposite side of beta. Adjacent is 5. And opposite is 12. So 5 over 12 is the cotangent of angle beta.